Okay, and then here we go. We've officially beginning class, and this is also for the asynchronous people here, and we'll kind of wave hi to you there. This is for our asynchronous people as well, so I'll be posting this after class. So a couple admin things here. We finished day one. You notice I posted an announcement yesterday. It was a summary of what we did. Make sure you go and do the GIS basics. Dr. McGinn and I are good at being proactive about the grading everything. So everyone who turned in GIS basics, and I checked to make sure your name was on it, because if your name's on it, it shows me that you can log into the GIS software. Few people already posted those, so just keep up to date on things. A couple people actually did it during class. Just a lot of pointing, clicking, all that other good stuff. Today we're going to do the same thing where we turn tabular data into GIS data. We'll talk about something called geocoding, how to turn addresses into points on a map, add XY data. There's a lot of valuable data sources out there. So after our break, we'll talk about that, and then we'll talk about different, the different data types and all that other good stuff that you'll kind of see. I'm going to kind of drag this thing over here. I'll drag this thing over here for now. And so down here towards the bottom, we've got just some videos here. So if you want to follow my videos for Introduction to ArcGIS Pro, these are all videos that we reference during my GIS classes that I teach face-to-face and online. Attribute queries, spatial queries, YouTube site. So today we're going to focus on geocoding, adding XY data, and then how to make maps. Because at some point in time, and Samuel's doing it right now for a project that we're working on, he's going to have to make a real world map that people can touch and feel, that'll be shown on a screen, that's going to be static. Even though most of the maps these days we're talking about are sitting right here on our phone that are going to look different on your screen versus my screens versus a tablet or whatever else we're looking at. And so today in day two, the project, and it's like a mini project for the exercise, is that you're going to be making data from a table. And we're going to look at some of the different types of tables right here. I think I've posted them after. I'll have to post a link to that here in a second, but I've posted a link to all the different types of tables sitting out there that you're going to be able to look at and view and kind of think about and think critically about, because the first question we ask when we do field mapping or any type of mapping is, where are we going to get the data from? That's the big question right here. And we got to think about data types. I've got a field called POP 2003. What type of data are we looking at? And I'll go back and kind of reference this map right here, where this is a map here in my house. I was kind of playing with it last night, so I clicked on a point right here, and then there is a picture I got with my daughter and her little friend right there. And these were captured at different times here. So, but I've got a picture right here. I've got some text up here. And when we look at the actual survey that we're doing in a couple days, because you're going to make one of these for your phone. These are all the different things that you could add to a survey, because we've already talked about nominal data, ratio data, interval data, the actual types of kind of data. But now we can add things like Likert scales, selection buttons, times, date and times, numbers, multi-line text. And then down here, like you can see that I've done, is that I've added maps, addresses, audios, images, file upload, signatures, all the things that you can add to a form. Because when you collect data, what is the information that you want to collect? It's a lot more than interval ratio data. It's imageries, it's location, it's ranking. Does anyone know what a Likert scale is? Has anyone heard that term before? What is it, Samuel?
The scheme to show your level of perception of
Yeah.
whether you agree with something.
Yeah, agree, disagree. It's agree, like it goes from 1 to 7 or 1 to 6. I always like 1 to 6 or 1 to 4 because there's no middle value. So you got to pick on one side of the middle one. You don't want 5 of them because the third one's in the middle.
This one, they don't have even numbers.
Oh, they have odd numbers on these? Okay. Okay, 3, 5, 7. Ratings, drop downs, single selects. Those used to be called radio buttons, if I remember right. And then you got multiple selects where you can select multiple features right there. And so you can add and edit these, because as we start talking about the different types of data, we're going to kind of look at some of those. My thing here is really, really simple. So I've got a map, I got a name, and then I've got a picture right here, because you're going to be creating one of these surveys, whether it's, you know, your jogging trails, the places that you ate at over the weekend or whatever. And so we could talk about the different types of data that we've got right there. So that's what we're going to talk about today. I will post a link here. I thought I had everything ready to go here, but we will talk about the Climate Prediction Center. I do have a link to that down at the bottom. And then we're going to talk about making maps, managing the lecture material. I do have a zip file here as well that I'll add after the break here. And then you can see tomorrow we're going to be flying a drone. One of the interesting things Dr. McGinn and I kind of just did before class is we went out and flew our handy drone. It's a Mavic 2. And then you can see the drone imagery that we captured just now. So we can look at some of the imagery that we captured of campus. So if you're familiar with campus, we've got like a little courtyard here. I'm talking more about the people who are joining us asynchronously. But we've got 2 buildings. We've got one to the one side of it, which is called Bright, some bio research technology enterprise. And then we got Mary Towns. And then in between those, we have we basically have like a courtyard in between, where we have like a community garden here. And so you can see the picture here from the courtyard right here. I'm going to do open with, I'll open it with this thing right here. But you can see some of the pictures that we took with the drone right here. And we took it from about 200 feet up. And so what I tried to do is kind of go do some coverage, because tomorrow we are going to go capture some imagery, and we try to get a number of overlapping images so that we can create something called the digital surface model. And this is really kind of, you can see the high quality imagery, you know, real high quality imagery that we have here around campus. So the big trick is, you know, and if you look at the pictures right here, and if you look at the details, so if I would go right mouse click view details, you notice here between 1206 and about 1211, you know, it only took about 5 minutes to collect all these images. To actually process these images and put them all into one place takes a lot of time, a lot of horsepower on your computer. Tomorrow we got a tutorial called Drone to Map that you're going to do. So if you want to install the software that's proprietary to GIS, and those of you yesterday at the beginning of class, if you noticed, when I was going through and giving you permissions for everything, one of the things I gave you permission for was Drone to Map. How to take all this imagery and turn it into a single image. Because right now, when we took this drone picture, basically all we did was just take our phone, put it about 200 feet in the air, and just took a picture. That's all we did, you know. But if you right mouse click on any of these images and go to properties and go to details, look at all this other imagery look at all these other things we have here. We have the date taken. We have the number of pixels, the camera maker. We go down a little further. We got a latitude, a longitude, and an altitude for each of these images right here. So this was 195. I think this is 195 meters above sea level, because when we were flying it, it was about 70 meters above ground, AGL. So this is ASL, above sea level. And so if I go to a different one right here and I look at the properties, you know, this is some more of the information about this. Because if I were to just go to a regular picture that I have here, if I just click on a picture right here and go right mouse click, I don't even know what I'm looking at here, and look at these details, there's not much information, you know, about these pictures here. You know, you can see how big it is. I guess I have a 63 gig picture. I didn't know that. But you can see some of that information about those. And so during our break, I'll add a couple of the links and references to the Google folder that we're going to be looking at. And then we're just going to talk about a couple of ways that we can join data, you know, create data from these here. And so I'll give my little shtick right here, tabular data, and then after the break, we'll post some things about that and look at that. And so when we look at attribute data, what is the information that you're going to want to collect? Because when we talk about GIS, those things, those elements in the left side of your table of contents are what we call layers, feature classes. Old school used to be called shape files and coverages, but they're called layers. So something like cities, zip codes, counties, COVID rates or whatever, which are attributes within each of these. And then a single instance of one of those is called a feature, and they're going to be aligned with a record in the attribute table. So the thing about a GIS, it's got this one-to-one relationship between features and attributes table. And those of you who took my 4010 class last semester, we downloaded the data, or we got the data for all the buildings on campus, and we noticed there wasn't a one-to-one relationship between those. So we got those buildings from facilities. We saw there were like 63 records, but only 60 features, and people were doing some really strange things with the records that we had to go through and clean up. And then they could be described a number of different ways. And so for all of those data that we looked at, all those zip codes, 763 zip codes that we looked at the other day, we saw a lot of interesting things. We saw, percent minority, median household income, COVID rates, percent Republican, all these other things that we could look at. So, this is under the lecture material under day 2, modules, right? I'm pretty sure. Go to modules, go down to day 2. And then the thing about GIS these days, which we'll talk about more tomorrow, is that each of them need a defined datum so they can be superimposed on top of each other. Because at the end of the day, our drone image that we captured yesterday, all it is just a picture. It might as well be a picture that I took here a class for the most part, but just flying up there. And we want to give that thing GIS coordinates so it can be superimposed on existing data. So we can do something called georeferencing, which we talked about in 4010, or we can run it through drone to map imager, image processing. And so something like sex offenders here that we see in Rockingham County are going to have different attributes than, say, a parcel right here that we have, as opposed to these are like Superfund sites in Minneapolis. Now, the one common thing about all these is that they have location attached to these. So here we have a latitude and a longitude and the number of pounds of junk they're putting in the atmosphere. Where back here, I've got an address right here that I can do something called geocoding. Have you ever typed in an address and it show up on a map? Have you ever done that before?
Or a hunting track.
Hunting track? What about on this thing? Don't you type in addresses all the time and the little blue dot pops up? Now try doing that 3,000 times. It gets a little bit harder. Or we've got some census data, and I know there's some issues with the census website because they're always updating it. It's called CEDC. Used to be called CEDC, and now it's Census Mapper or something like that. Or if we find some interesting data on the internet that says graduation rates for 2007, graduation rates for 2012, I want to make a nice pretty map of it like I showed you yesterday. Or this is some real ugly stuff right here, where we're looking at the number of people aged 0, 1, 2, 3 by county for the year. And a lot of times if we get like population data, you're going to see some of the challenges of making some sense out of these here, because I want to map people age 16 by county for Western North Carolina, Buncombe County, males, females. And so a lot of times we don't suffer from a lack of data. We suffer from having way too much data and figuring out what to do with it. And I think when we look at the, I posted a Google Drive of like voting data that Dr. McGinn and I have worked with, and it has just a list of every like libertarian voter in the state. And that's tens of thousands of people that you need to go make sense of and map and figure out what to do with it. And so imagine looking at like 7 million voters in the state of North Carolina or 30 million voters in the state of California. Now, we've talked about these before, attribute tables versus standalone tables. In my classes, I don't give this nice, pretty chart, but in this one I do, because attribute tables are typically going to be linked to points lines, and polygons. We've got points, lines, and polygons because our main goal in this class today is how do we turn tabular data into something that we can map? I downloaded something cool off the internet. How do I turn it into a map? I downloaded all the crimes. I can go to the Greensboro Police Department and they give me a list of addresses for all the crimes that occurred in the last week. We can go to the Open Durham GIS website, which I think I have a link to. It's got all the crimes that I can filter and download over the last 5 years. I want to turn those into a map. How do we do that? I've got lots of cool data on ADHD. I'm working with, if anyone went to the graduation, I had a PhD student who's working in the integrated biosciences, and she's working on African American female breast cancer rates. Now, do you think there's a database out there of African American female breast cancer deaths in the state of North Carolina? No. But I've got a table, I got a big gigantic table of every single person who died over the last 17 years. So I can add it to 2003, to 2004, to 2005. How big do you think that table is? It's really, really, really big. It's about 1.7 million records. 1.7 million people died in the state of North Carolina. Imagine working with an Excel spreadsheet that has 1.7 million records. Here with the county database yesterday, we were working with 100 records because there's 100 counties. We're working with 763 zip codes across about 150 attributes for that. 7 million records with about 40 attributes. And the difficult thing was in 2014, they changed all the names of their attributes and added new attributes related to tobacco use. So when you died, they could put a little Y or N if you used tobacco, or if it was a workplace injury. And then they changed the attribute names from birth county, like B_CNT to BRTHCNT. Now, that's no big deal, but if I'm combining stuff from 2003, 4, 5 with stuff from 2018, 19, and 20, those columns don't line up, and there aren't the same number of columns. So just like I was saying with the drone, it took, Dr. McGinn and I out 5 minutes to go fly this whole area right here, but it's probably going to take us 5 hours to go and make some sense of all the pictures that we took, which is about, 500 meg in size. We only took about 60 pictures and they're about 8 meg in size. Do the math on those. We're looking at about a half a gig of data that needs to be processed. And so this is the same thing that we talk about here. So I'm looking at here in our room here, maps of ulcerative colitis, and we had a student who went and mapped SIDS deaths, and using the same type of database. So making the appropriate queries, which we took from these standalone tables. So going back to these attribute tables, the attribute tables typically have a one-to-one relationship between the features on a map. And they also contain a column called an object ID, which serves as a link between your attribute table and features on your map. And then it also contains some extra columns. So if you see something there like area and some really big number like 23 billion, well, it's 23 billion probably square feet because we're working with the North Carolina state plane projection. All that stuff, so the points, lines, and polygons can be superimposed on each other. Stuff that we don't need to worry about. With a standalone table, this is kind of the space that I live in. Dr. McGinn and I kind of live in the idea of, all right, we want to map COVID rates by county. We want to map voting rates by zip code. We're going to get the data because the North Carolina, Board of Elections has a big, gigantic list of every single person in the state of North Carolina who voted in the 2020 general election and how they voted, whether they did early election or mailed in their ballot or showed up on election day. Now, do you think Excel can work with 7 million records? Excel does not like 7 million records. It kind of craps out at about 1 million records. They have something called the Power Query Editor, which is able to kind of run some really neat pivot tables on that stuff, but it takes a long time. It doesn't contain an object ID. It's stored as spatial data. And so when we want to turn cool data sitting in Excel spreadsheets into something that's mappable, we need something like a county name, or we can run something called the summarize. It means count the number of times something appears. This is what I did with our PhD student, because we had 1.7 million records of people who died. we looked for female, African American, breast cancer deaths, and then grouped those by zip code because we don't have exactly where they live. We had their exact zip code. So I just counted the number of times each zip code appeared for each of those 22,000 people who died. So we got something called Summarize. And probably does Summarize ring a bell for you a little bit? Okay. Summarize rings a bell. We have something called the tabular join, which we'll talk about. We'll talk about geocoding and then something called adding XY. And so when we look at spatial data, this is what we see. We see Alamance County and Allegheny County, and we can see they're highlighted in the table, they're highlighted in a map. We got an example of a standalone table where we're looking at 2020 infant mortality rates right here. And so we can see the infant mortality rates by non-Hispanic white, non-Hispanic white deaths, non-Hispanic African American, non-Hispanic American Indian, non-Hispanic other rates, and the Hispanic rates grouped by county. And in these infant mortality rates, and even more so, we can look at things like cancer mortality, age adjusted to 2000 US population standard. Like we talked about yesterday, and like we did with this student, is that basically when you're mapping death rates, all you're doing is mapping where the old people live. And you're going to say, no, duh, of course that makes sense. And so you see all this stuff over here that says age adjusted to 2000 US standard population. That age adjustment basically makes the average of every county to be the same. So some of the things we can do with these tabular data is that we can sort, query, summarize, calculate statistics. And so we can right mouse click, and all I say for a lot of people is when in doubt, right mouse click, and we can create something that looks like this. What's this chart here called? Does anyone know? What's this chart called? And those of you online can, join us too, or who am I going to pick?
Histogram?
Histogram, good. Who was that? Was that Barron?
That was
Barron, yep.
Barron, good. This is called a histogram here. And so this is what we're looking at here is normalized data, meaning it's high in the middle, low on the ends here, kind of like football wins, like I talk about. Most NFL teams win between 6 and 10 wins. You don't have a lot of 14s, you don't have a lot of zeros and ones. And so when we look at normalized data, this is typically what it looks like, and it's got some sort of bell curve where they're high in the middle. And so those equal intervals that we talk about are a little bit more difficult to do. So we've got a histogram right here that shows us the mean, the median. We've got standard deviations. Those are just measures of central tendency or descriptive metrics to describe the data set. Descriptive measures to describe the data set. And then when we look at the intersection of our columns, our fields, and our rows and our records, these things are called cells. But, data comes in a lot of different forms. If I go over to the Greensboro Police Department, they've got a 5200 block of Eastern Lane by the Greensboro Police where there was a vandalism at a residence on this particular incident ID at this particular date. So I can go and download these data. And hopefully next spring, we're going to be teaching a class called data science where I can save these web pages right here, or I could do something called web scraping. Has anyone heard that term before? Web scraping, which I can just pull the pertinent information off of this and turn this into a nice Excel spreadsheet that I can turn into a GIS. Now, Greensboro Police, we're talking about the Greensboro Police, we're probably going to have to assume the city is Greensboro, so you're going to have to work a little magic here. But in Excel, we can calculate new values for new columns. So we can always extract brand new data here. So if we look at something like this, we have 2010, 2020. We can look at the natural increase. We can look at migration. We can look at rate of natural increase, some of the things that you talk about in your human and world regional geography classes. And then we can calculate something like percent growth. Because if I say that a county gained 19,000 people, I can see Alamance County between 2010 and 2020 gained 19,000 people. Is that a lot or a little? Kind of a lot, but depends, right? Depends on how big the county is, okay? This is probably relatively high for Alamance County, but this county only gained 406. But if you notice here, this county is almost 20 times smaller. Allegheny County is almost 20 times smaller than this county. And so it depends, okay? And so I can calculate these nice little percent growths. Okay, your percent growth is new minus old divided by old. Multiply the whole thing by 100. Those of you who know me, I hate having fractions like 0.72, 72%. I just multiply it all by 100 and make it 72% because I think it gets confusing, especially Excel back in the day. And I probably have some trauma from doing percents in high school or whatever too. But we can see some of these instances right here. So that now I can calculate the percent growth. So now I can see, Allegheny County only had 3.4% growth, 3.64, where Alamance had 10%, and Cabarrus had 21%, and Camden had 5.6%. Then we do have some counties that actually went down. And so this is this is a pretty neat thing that you might do someday in human geography or your population geography, where we have birth, deaths, natural increase, and migration. So we can see some counties like Anson County in North Carolina that actually have net negative migration. Because especially in the United States these days, where's population increase happening? It's not from people having people, it's from migration, not only from other countries, but from other places due to push and pull factors. And so I think I got this from the state demographer. So we can do some really neat data on this here. So if you're thinking about projects and things like that, I think something like this, I'm just pulling one out of the air here, kind of looking at the different dynamics of county level migration would be really neat. And I bet you there's going to be spatial patterns related to this here. In addition, we've got non-spatial data right here. We've got data from the census. You were saying this link is bad still?
It's not pulling.
Oh, it's not pulling up. I'll update it here. We got information from the Department of Public Safety. This is a really neat one that shows the number of prison entrants in the state of North Carolina that you can map by county. And then we have some information from the North Carolina Department for Health Statistics. So if we look at something like the Department of Public Safety here, this is for the people online here, and then this is for the people in class right here. But we can start generating reports, and then we can just look at prison entries by county. And those of you looking right here, we've got prison entries by county, and then we can define the report, where I can look at, county of residence, add items, continue, select all. And so right here, I've got a big gigantic list of everyone who entered prison in North Carolina between 4/1/2022 and 3/31/2023. Obviously, these numbers would need to be normalized by population. And so we've seen some really neat projects from students who've done things like this. Okay, what is the other challenge that you see here? I look at these data here. I'm showing the people in class this right here. What's the one challenge about the county name that you see? What's the one challenge? Everything's capitalized. When you look at it in an attribute table, is it capitalized? No, it's in proper case. So you're going to go and retype all the county names so that they appear that way? Is there a way that you can magically change that? You can change the setting. There's also a little formula called upper and lower, things like that. A lot of times when we talk about addition, subtraction, and mathematical operations, there's whole accompanying string operations so that we can change this to what we call proper case so it lines up, because computer's stupid. It doesn't know capital N, capital A, capital S, capital H is the same as capital N, little a, little s, little h. And so I know from experience, I've seen people in the past go and literally start retyping these things in for all 100 counties. And there's ways to change case. I know you can do it in Word, and you could probably do it in Excel, but I know there's Excel string formulas that go through and look at this. And so, make your life a lot, make your life a lot easier here. And so we can look at things like cancer mortality rates. And so we worked with Michael. I think I thought I saw Michael here somewhere, but Michael, who was here yesterday, he did something on meat production by county, pre-COVID, COVID, post-COVID, or whenever post-COVID is going to be. But when he got those data, those were as PDF documents. So basically, he had to convert that PDF to something, kind of get rid of all the junk in there, and then bring it into Excel so that we can do something with this. And so when you zoom in, you see nice things that kind of look like this that are ready to be downloaded right here. Alamance 13.6, Bladen 15.5, Burke 16.8. These are the things that I want to go and map here. I've got little stars right here because in Camden County, we've got unreliable data right here. We've got unreliable data right here with 6. And so we have this thing here called the small number problem. I know Samuel's heard of that here, but a lot of times if we have small number problem, if we're looking at like infant mortality increase, if we go from 1 to 2, we had a 100% increase. What happens if you were to map that 100% increase? People are going to look at that map and say, wow, what's happening in that county that had a 100% increase in infant mortality when it really went from 1 to 2? I'd be much more concerned if it went from 100 to 200 than from 1 to 2. So that's what we call the small number problem, because the changes in small numbers are going to increase things. So if we calculate this rate with only 6 right there, it might be really high because we just happen to have 6 people over this time period that died of colon rectum cancer as opposed to anything else. The other thing that we've got going on are the different types of field types. Now, in this case, we're only talking about tabular data sitting in a spreadsheet. We just showed an example. And when you start making your survey in a couple of days, what's all the information that you're going to want to collect? Do you want to collect a picture? Do you want to collect a website? What do you want to collect? And there's lots of neat ideas that you can do there, because we're going to start that survey, and then we're going to do some hands-on things where we insert those into a web map, and then we insert those things into a web app that I've shown you that I'm actually updating on a regular basis here, which is kind of neat. And so a lot of times with those text fields that you have, we have things like texts, dates. Remember before it said, hey, I want to input a date. So when you collect that image, it's got a date which is stored differently than short numbers, long numbers. Short and long are usually integers. And then we've got blobs and floats, or another word for float is called a double, meaning it's double precision. Just because 3.666, the number of ones and zeros to store 3.66 is probably as much as it is to store 97,400, or the date, or the short in this case, which is relatively small here. So we can calculate brand new columns here. And when after the break, once I get everything uploaded, once I get the project uploaded, I think it's uploaded there. I just need to make it visible for everyone. I think that's what I did wrong. Is that we can go through and add brand new fields here. And so we can do something in our fields view that allows us to add brand new field, and it says short, long, float, double, date, text, blob, grid, raster. These are all the different fields that you can add. Okay, with our hands-on surveys, we can add images, videos, uploads, all these other things. Typically in the typically in ArcGIS Pro, those are stored within this big umbrella called blob, binary large object, that you can stick videos and URLs and pictures or whatever you want to there. Because you notice I took a picture of my kid and the fire and all that other stuff, and that stuff stored in a database. It's got to be stored somewhere. And then Mike Wallace, one of our grad students, he's working on a project where he's linking to pictures, linking to files, linking to links, external links that we've got right there. And so you can pretty much link to anything right there because you can speak to the amount of data precision that you can store. Remember that word precision and accuracy? If you apply for like an entry-level GIS job, someone's going to ask you, what's the difference between accuracy and precision? And if you ever looked at my Google Drive before, if you ever looked at the link to important forms, I've got a supplementary application from Durham County where someone asked, one of our students gets asked, explain the difference between accuracy and precision. It's pretty neat. And I think another question was asked, explain the difference between topography and topology. And so we'll talk about some of these things here. But the number of decimal points, the alignment, you want to pad it with zeros and all those other things to make the numbers look nice and pretty, because Samuel and I and a couple other students here, we're working on a paper here. I don't want to see 3.72529. I just want it rounded to 2 decimal places. Okay, we're looking at the number of stores that are going to be numbers. I don't need to see 3.000. I just want to see 3. I don't need to see 4.01. I just want to see 4. And so the way that we set these up, and Samuel was able to do it in the symbology editor, right? If I remember right, Samuel was able to do it in the symbology editor, or you can store it. You can also do this in the fields, the actual physical fields right here. And so we can add new fields, and now we can just go and calculate new fields by clicking on the actual field names. And so these little exclamation points, just like we did yesterday with the queries, this field calculator goes and generates these automatically. Because at the end of the day, what we want to do is create a nice, pretty map. So your submission for today is going to be a nice map here. Now, I was just kind of playing with this stuff here where I inserted pictures. So you can insert a logo. You can insert a scale bar right here. We talked about the symbology. I inserted another logo over there. I inserted a legend over here. You can insert a title up at the top right there. And so up the top, and what we'll start talking about today is all the different ways to make a map, because we've got those web maps that you can, save everything, but it's going to add the scale bar to it, because Samuel, the map he's making for me, is going to have a dedicated scale bar. The maps that I put on Survey 123, I don't put the scale bar because I'm going to zoom in and zoom out, and this thing is going to change. It's going to be dynamic as I zoom in and zoom out. But I can also add a legend if I wanted to. And I had those red points that say these are my surveys. I changed the name of them. I changed the Tim Surveys point instead of like E00234 or whatever name that Esri gave it for me. And then I can put logos and whatever else that we have in here. We can also join data, okay? Join data. We can, Dr. McGinn and I live over in Guilford County, so we can do something like a Guilford County parcel search. And so every parcel has a unique ID, just like everyone here has a unique 820 number or social security number. We can click on it, and then it'll link us to all this special information right here. Your 820 number. Okay, in this tutorial, and I'll post this as well. But in order to join data, and this is our big thing that we'll talk about after the break, is that I've got a link here to some standalone tables. This is the link that I wanted to provide here, and I want to kind of double up my screen right here. Here we are. There we are. Okay. All right. So what we have here is an example. These are just some tables that someone might download on the internet, and I had to change the display so the people joining us online, the people joining us asynchronously could look at this. And so typically the questions that we have are, we want to make like a school suspension map or something like that. We're going to get this from data that we might download from the North Carolina Department of Public Instruction. This is an example of all of the deaths. So this death data that I was talking about, I can go to the North Carolina Department of Vital Statistics and download a list of every single person who died. And when I open it up, this is what it looks like. Now, for that PhD student, we combined 17 years of this stuff all in one. I'm going to click on the data here. And this is what it looks like in Excel. Because the main thing, since this is a GIS class, what do we need for a GIS class? Location, location, location. So we need something related to location. And so this is a list of every single person who died. And so we have something here like D year. Well, what do you think D year means? It's the year they died in. D date, the year they died. What do you think M and F means for sex? Male or female? And then it's got some codes for like race, Hispanic, age, marital status. I don't know what DUDC means. And if I go a little further to the right here, I go a little further to the right, I have the codes that they died. Typically, you're given a code. When you die, you're given like a code of what you died of so that people like us can go and basically query what you died of. And so we've got students. There used to be a really cool poster in the back where we had a student. She was a bus driver. She came to school after she drove a bus in Wake County, and she wanted to look at the types of deaths for kids ages 15 to 25. So she queried out every single person age 15 to 25, and then she ran something called a summary on just those kids right there, or not kids, but people right there, and looked up the codes to see, okay, code C349 appeared 72 times. Code F101 appeared 14 times. Code E46 appeared 47 times. And so this is what this death data looks like here. If I go all the way to the right, I have something here called zip code. Zip code means it's just a polygon of the 763 zip codes that have spatial location attached to those. And these new ones have, is it a work injury, yes or no? Were they pregnant? Was an autopsy performed? And did they use tobacco? Yes, no, undetermined, or whatever. So these are some of the new fields that were added right here. But if we look at all the deaths that we have here, you know, we've got about 96,000 people who died that we can query these data. The very easiest thing that I can do is I can right mouse click, create a summary table, summarize these data, or I could query out different codes. Typically with these ICD codes, it's called the International Classification of Death. Anything that starts with a C stands for cancer. And so I can query out anything that starts with a C of those 96,000 and then kind of go from there. But this is just an example of one of these that we have. So if you're interested in doing some sort of kind of cancer research or whatever, we've got the 2017 data sitting right there. Maybe we can go download the 2013 data. Is there a difference between these? And then, like I was saying before, that student that I worked with before, she wanted to look at the student, people aged 15 to 25 in 2014. And so she downloaded all the people aged 15 to 25. She just ran a simple query. And then she wanted to look at the ICD code. And she found the ICD codes for these. A lot of them were suicide, drug overdose, car accidents. You know, right here. And so we looked at these here. So this is from, her name is Angie. We have some information from Durham Police Department crime data. So this is some crime data that we've got from the Durham Police Department. We'll talk about this a little bit after the break, especially if you want to build a crime database in support of our classes. Typically, when we go to the Open Durham GIS website, this is a list of all the crimes here. It's got the date reported, a month stamp. So we got these different months. It's got the, if you look all the way to the right, we've got the address. It's got the address right here. And so if we got an address, can we make a location out of it? You bet we can. Of course we can. Here's another neat one. This is the maximum temperature. This is from the NOAA website. So this is the maximum temperature. So at this latitude, this longitude in Chicotney, Alaska, it got up to a maximum of 21 degrees on that day. You know, we've got about 6,000 of these points from the National Weather Service or NOAA throughout these. So I think, you know, Dr. McGinn and I think our skill sets are trying to turn interesting, you know, how do we turn all this stuff into GIS data? I think we have a pretty good place there. We've got SNAP locations. Here's a really interesting one of supplemental nutrition and aid programs. Excuse me. But these are the SNAP locations, I think, for the entire United States. So these are all the stores that offer SNAP benefits that we can download from the USDA website that we can query and turn into a map. The last one I'll kind of show right here is we've got libertarian mail-in votes. This is kind of the space that Dr. McGinn lives in, but we can download a list of every single registered voter for the state of North Carolina. That's like 7 million of them. We can also download every single voter who voted in the 2020 election. So I think that was like 5.5 million people who voted, and how they voted, and maybe not how they voted, but how they voted, whether it was mail-in, they showed up at the polls, or they did like early voting or whatever. And so I went and queried out just the libertarian voters. You know, look how big this data set is here. Now, this is all information stored about me and you right here and right now. We have voter registration number, ID, your name, ethnicity, gender, you know, the address that you live at. This is your ballot here, zip codes, everything else here, you know. And some of these are spatial in nature. Obviously, your address is spatial in nature, but your district, when you voted, your congressional district right here. And but we did this at the zip code level because we could have mapped these all at the individual level, but we mapped them at the zip code level because we were comparing these to COVID rates. And the best levels, best scale at which we have COVID data is the zip code scale. So I can't do voting data at the individual level and compare it to COVID data at the zip code level because I'm trying to compare the two and I only have zip code level data. And so a lot of times if you're looking for correlations, you're going to be kind of hamstrung by scale. You know, you only got scale at the, you know, zip code level. That's the best you're working with here. But I was able to kind of group all these things. And so Dr. McGinn and I looked at the percentage of people who vote by mail by county. Believe it or not, it's spatial in nature. You know, you can put it on a map and see distinct patterns with it, even though you think of me showing up at a polling place to be kind of a individual decision, which is going to be different than yours, and someone else's. But these things are all spatial in nature, which I find incredibly interesting. But the thing about this, libertarian voters, there's probably tens of thousands of these here, just like those death records, and we can go and turn these into maps very, very easy, you know, extremely easy. I'll mention a couple things here, then we'll take a quick break, and I'll get my things uploaded here as well. But when we join, and then I won't mention anything. I won't mention much about I won't mention anything about geocoding here. I'll get that project up there as well. But the one thing, when we download and add data, we click that black plus sign up there. And today we're going to do a little bit more clicking that black plus sign because those data can live anywhere and connect to our folders. Because a lot of times when you create a new space in GIS, you got a new folder space sitting right there that you can connect to, add stuff to, and everything. And so I have a standalone table. I have an attribute table. I've got a standalone table. I know this is a standalone table for a couple of reasons. It's got the little .csv right here. In addition, I don't see anything that says like object ID or anything like that, so that I know it's not connected to a point line and polygon. I also see there's 102 here where there's 100 here. So it might have a couple of extra column, a couple of extra rows down at the bottom. But one of the big challenges we have is how do we add this table to the end of this table? And what we basically need is something called a key. Now over here it's called name, over here it's called county, because what I want to do is just add this to the end of this. And then, like you did yesterday with symbology, instead of me mapping median household income or spending on fruits and vegetables, I'm going to just map July 2015 or whatever attribute that we want that was just sitting on the internet a few minutes ago. And we're going to do a couple examples with that. And then now we can go and July 2018, July 2019, we're sitting right there that we can link and join. We can go and map the population 2019 just like this. Now they need to be a key. And like I said before, computers are stupid, so that capital Florida doesn't equal this. I know this guy's out of date these days, but you know what I'm talking about, right? FLORIDA. And then we can also run statistics on these like mean, median, count, histogram, skewness, kurtosis. Don't worry too much about those. They just measure how this curve basically looks right here. So if we're mapping something like average household size, it's fairly easy to do. And then the other thing that we can do is run something called the summary. Just like I counted the number of times that each zip code occurred within each zip code occurred for the number of deaths, African American deaths, I can do so on like the day of the week. Which day of the week occurs the most on 2,260 crimes? Who's going to go and count those? Not me. I'm going to create a nice little summary table. And it's going to give me a nice little summary table that says Friday 317, Monday 294, Saturday 322. And then the same thing. This is the project that we did with the SIDS deaths, where we had a student from this poster over here who had been impacted by SIDS, and we downloaded all the SIDS deaths. You can see that they got a zip code right there. They got these are all zeros because you can see sections 1 and 2. You can see how old these kids were. You can see the race. And so what this student wanted to do was look at the location, race, and gender of kids who die by SIDS. And so you can see it's largely white, African American, a little behind, and it's largely male also, because I guess infant mortality rates are really high for males compared to females. And then it evens out when males do all the stupid stuff to eliminate themselves. Yes. And so we can make a nice little map like this. This is a map of SIDS deaths that was just sitting in a big list of deaths over a 10-year period. And now we're mapping these. And then the last thing I'll mention here, because we'll talk about geocoding later here, is the Climate Prediction Center. And so I can go click on the Climate Prediction Center. How much snow? This is going to be downloaded as a TXT file. All it is just a comma separated file, meaning if I were to open this up in Excel, it would have all brand new cells. Wherever it sees a comma, it makes it a brand new cell. And so one of the big superpowers that you need in GIS, they were talking about superpowers at NASA. The one big superpower is knowing who to talk to for stuff. I'm still trying to learn that one. But one of the big superpowers that you need is how to go between different data formats. Because that data sitting at the Vital Statistics database is something called .data and .tab. And so I would imagine tab data is whenever you hit a tab button and go over to the next column, it's lined up in columns. So wherever it sees a tab, it makes it a brand new column, where this thing is a text file that's going to be separated by commas. So going back and forth between these things is really powerful. And then when we have add XY data, I've added that data to ArcGIS Pro. This is what it looks like. It's got a new column called lat, new column called long, LO1 for longitude, and we just added as a geographic coordinate system because we know this anything with GCS is going to be latitude and longitude, those angular units that we don't like working with because we work with sines and cosines and all that other good stuff. But I know these units here aren't in feet or aren't in meters or anything like that, because once in a while you might get a data set that looks like this. This definitely isn't latitude and longitude. This is in state plane feet. And I used to work with these in the military back in the day. They'd give us big lists of these, and we'd have to basically make sure it lined up with what we should be looking at. So if it was like in the Atlantic Ocean, all right, I better change it to meters instead of feet because it multiplied it by a scale of 3.28. I think we did that in geostats one time, right? If I remember right, we were putting stuff in the middle of the Atlantic Ocean because they were storing it as meters. We said it was feet. And remember, these computers are stupid because all we want to do is make all this stuff line up. Because when we add our data, this is what we want to see. Our crime data, when we add it, I want to see it line it up on top of something that's familiar, and that's what it should look like. We'll take about 10-minute break here. I got to go and add everything here or make it visible. So we'll take about 10 minutes and then we'll open up the project and kind of start working with some of these tables.
I'm trying to click which ones. I couldn't tell which one were. Probably because I'm an instructor, so I guess the visual will be.
Yes, they're all, yeah.
That's what student view. I couldn't.
Yeah, I messed something up here. So
So he sent. We got an email. He sent his acceptance on.
okay, let me
Right, right. I just wanted to know, I mean, it told me to take a sample anytime it's clear, but I didn't know if there was a certain time, like a certain window of time you wanted to have it. You told me where the bag is and you showed me how to set everything up. I just wanted to ensure there's that specific time that you want me to collect the data. It's just based on the sun. Okay. Wait, so say that again? Oh, so why would it be 10, 12, 2, and 4 if it's depending on if it's a clear sky? Okay. Well, let me surprise about time. Just call you back. I mean, I knew for the air quality sample that we had to take, 4, 2, 4, and 6, but with your data collection, it was based off of them being clear sky. So that's why I don't understand, not like understanding the time of taking 4 samples because if there's clouds, and 2, how are you collecting that sample? So I'll call you back after the class, but to get some clarity. Okay. You collect data when there's no clouds out, but before the clouds come in.
I'm not sure. Okay, we're going to kind of do some hands-on stuff for about 45 minutes, 50 minutes, and be out of here in 2 hours and be out of here within 2 hours and give you a new charge here. Now, the first thing I want us to do, everyone can hear me, right? I think I turned everything on.
Yes.
Okay.
Yep, you're good.
Okay, good. So in lecture, okay, I'm gonna click this button here, and if I go to student view here, so if you go to student view in day number 2, I added a couple things here. First of all, in day number 2, I talk about what we want to do. I've got a link to geocoding services. I also have a video on it. I'm going to show us a quick little geocoding video in a little bit because I extracted out some data. I did some pretty neat things with this. I also have a link to the Open Crime GIS website. So Durham has what we call open data, and it's kind of initiative, or it's a technology by Esri, the people who make our software. And if you click on it, it's got dashboards, which we're going to talk about on Friday. It's got some data catalogs, some story maps that we're going to be doing on Friday, and some maps and apps right here. And like I showed before, I got a map like this, and I can click on the share button, and I can create an instant web map just like this, stick it onto the internet, just like I did my Survey 123. But my Survey 123 allowed me to do it. I created the survey on my computer. Ever since then, I've just been doing everything on my phone. Me personally, I like using my laptop. Did you find the password for that thing yet?
I think so.
Oh, is it one of ours or one of Zarzar's?
Text ours are.
Oh.
It's faster, so.
Oh, okay.
Yeah, we're in.
So no juicy 72. Okay. All right. So when we look at this Open Durham website, this is a pretty powerful tool. What I'm trying to do for us is that I have a grad student working this summer who's going to be creating an Open Durham portal for us on the NCCU campus. Hey, Baron. on the NCCU campus. So stuff that you want to download that you think is important, some of Dr. McGinn's voting stuff, or I just want to download schools or golf courses or whatever, things that are important to us in our research, we're going to be able to do that. And I think that's going to be a project that probably Chima will take over moving forward. But I could type in the word, say, crime right here. So I can type in the word crime. And then this is just for Durham, and it's got DPD, Durham Police Department crime incidents. It's got arrests. At one point in time, this used to have the sheriff's office, but I don't see it here right now, or they didn't stop allowing it. But you can see this is called National Incident-Based Reporting Standards. This explains it a little bit here. And this is where I typically get these data from. And so I can go and download these data right here as a spreadsheet, calls for service. There's a lot of different services that we have right here. It's really, really neat. We have students, a couple of students who work for the city of Durham and Durham County. We got like 4 of them off the top of my head who work for the speed hump program, like mapping all of the speed humps, doing stormwater. Another one kind of works in stormwater, and another one named James kind of does some things with zoning. And he actually went back to law school and did some pretty interesting things. But so when you click on day number 2, I've got a link to that. I've got a link to some suggested training. So if you want to be a whiz at geocoding, be a whiz at geocoding. Mapping addresses and places, displaying coordinate data. Like Guilford County, they have a whole person who works for the school district. All they do is map school districts, map students. Chris, you know who that new person is? Do it, Tommy Patterson.
Really?
Yes, he's doing that over there.
Are you serious?
Yeah, I saw that on LinkedIn.
Because I sent him, he was working and doing some curriculum development
Yes.
at Apple Hill. And then I sent him the ad.
Yeah.
And then all right.
Yep, he's doing that. He's basically doing for Guilford County over where Chris and I live. We're going to map the new kindergartners, bus routes. I don't know if they still have it in Guilford County. 0 period. Do they do 0 period? Okay, my kid used to do 0 period so she could get out of the house early or whatever. But so map all the school boundaries, census data, all this stuff. So if they need to change school districts because these schools only have a certain capacity, they'll change school districts and sending districts and all that stuff. So someone who applied to one of our positions a few years ago, he's actually taken on that position after working out of state. But this is the space that you would live in: geocoding, crime. That crime mapping class that we're going to have, one of our first lessons is going to be geocoding data. How do you turn addresses into points on a map? And in this class here, when we open everything up, you're going to see I've got a few different tables up there of the different ways that you can turn tabular data into maps for the most part. I also have the exercise. We'll talk about the exercise in a little bit. I got a link to some standalone tables that are sitting in my Google Drive. And so what we looked at during the lecture, I just got a link of some, tables: homelessness, ADHD rates, libertarian voters. I didn't want to put every single voter because I would, clock up my Google Drive or whatever. But you can just see some of the different examples of data sitting out there that you can turn into spatial data, because whenever you talk about a project, we had Benjamin the other for his project in 4010. I want to map all the recipients of the food giveaways in Durham County. Well, how are we going to make the map of those? Okay, what are we going to have for those? And then I've got some videos here on adding XY. From the NOAA website. Real quick, I will go and add this, because this is a really powerful site too, called the NOAA Climate Prediction Center. So if you're doing like any sort of climate mapping, we can do that. So I'm going to leave student view. I'm just going to add an external link right here. Spell the word prediction. And so you can see down here the NOAA Climate Prediction Center. I can right mouse click on this, open up in a new tab. And then typically sometimes it says insecure content, but I've got daily snowfall, I've got air temperature. And so you can see for the maximum temperature, I can download this right here. So I can download this text file so you can see at latitude 50, longitude -112, using this unique ID in Acadia Valley, Alberta, it got up to 59 degrees Fahrenheit. And so I can right mouse click, save as. I can save this text file and bring it directly into my GIS. So I can go to my map, my add data, and now I can, just like we did in our ArcGIS, all of our classes, I can navigate to my computer wherever I saved it. So these days with the cloud, it gets trickier and trickier because now you got another set of locations where you're storing data. So instead of me looking at my downloads or my C drive or my external hard drive, I've got this whole thing here under Porter where I can look under my content, my organization, all the stuff that I've added so that if you're signed in at NCCU, we've got here. I've got our groups right here. So all the stuff for the 4950 class that I've added for you here, or we can look at ArcGIS Online, other people that have contributed to ArcGIS, or the Living Atlas, which are things created by Esri. But for now, what we're going to do is we're going to open up the day number 2, the day 2 in-class exercise. So I want to make sure everyone's able to open up the day 2 in-class exercise, and it's going to look something like this here. I want to make sure Barron's got it. I'm pretty sure Samuel's got it, and I know I want to make sure Sade's got it. Got a log in. I think yeah, let's see if we've got. Just click extract too. Now let's go back here. There. Yep.
Get password back.
All right, you got it, Barron? Oh.
Did you change it? Try the old one.
We got those double sequence probation ones that we can.
That could be it. Yeah, this has DGI on it, but that's.
Oh.
Can we do?
Oh, we can connect that thing to the.
Well, I'll connect to the internet. But no, I was thinking about it for me and Rebecca's project.
Oh, yeah.
Can we can access survey 123 through the internet?
Okay. Because you're going to be connected to Wi-Fi. Because
Right, yes.
anything hanging off a tower should be able to do it. You got a couple months.
Yeah, figure it out.
So,
It's like,
did you answer anything else?
that it might be, yeah, you may have never activated it, maybe now.
Check your.
Yes, so there.
Did you get everything Hensley and like last day?
Should have been yesterday around this time.
Let me log in. It's there.
So, where'd you guys access?
Yes, thank you. Oh, so you've already been in sense. So where is? We've got everyone in second class right here. Now, what we're looking at here in our table of contents, we see the major cities that we saw yesterday. We see counties. And if I right mouse click and open up my attributes, I don't care too much about the POP 2010, POP 2013. I care more about this column right here called name. And I notice that it's in proper form. All that means is that the first letter is capitalized, everything else isn't capitalized. Because a lot of times, if you download data from the Department of Public Safety that has prison entrance, everything's going to be uppercase. So you got to somehow convert everything to lowercase and not do it by hand. Because if I got to do stuff by hand, I'm just going to make one of my grad students do it by hand because I'm not going to do it. So I will not do it by hand. And so there's simple little programming tricks to do that because a lot of times people think of field calculations, adding one column plus the other, but we can do things with, that's my fault. We can do calculations with these. Okay, next thing we have is zip codes with voting data. So if we just look right here, I've got an ID, and this ID is the zip code name, and it's also got the 763 zip codes. The one thing I want us to notice here is you notice that this ID, it's a number, it's left justified, but these other numbers here are right justified. Why is this left justified, but these are right justified? Doesn't change. What else? Any ideas from the people online? Why is the ID column, even though it's a number, why is it left justified, but the things like pop density, white, median household income, why are those right justified? Data format. What's the data format? ID is being treated as a string. Okay, so if there happen to be any leading zeros, where I grew up, our zip code started with a 0. And so it includes that 0 right there. So those are some of the mistakes people make where that at some point in time, if I go to fields view and start to add brand new fields right here, and so you can see this ID is a text and the length of it is only 5 because, well, zip codes are only 5 letters long or 5 characters long. And they could start with a 0. And since it's text, it means it's not going to get rid of that leading 0. But I can go down to the bottom here and start adding brand new fields here. So I can say, something called like sex ratio. Sex ratio is the percentage of males versus females here. And then under these here, instead of long, I can make these short, long, float, double. Short and long basically truncate all the decimals. Okay, so you lose granularity. This is a word that we talk about from time to time with like your GPA. Do you got a 3 or you got a 3.48 or 3.489? How much precision or granularity do you want with those data? And so sometimes people go through the mistake of making this a short, so that sex ratio is a 99, 100, 101, 102, 103, where I want 99.72, which can be differentiated from 102.7 or 99.6, and I can sort these because you're probably only going to have sex ratios between 90 and 110 for all 100 counties in North Carolina. So we can go and add brand new columns and calculate these as well. Okay, I also have my counties, I have my major cities, but now in standalone tables, and I'm going to click no. Now I've added in standalone tables. Now to add standalone tables, I can go to my black plus sign and I can go to wherever I downloaded it from. And this is where we all kind of run into issues because whenever I click download, I just click save. Now, where is it save? Wherever it wants to save it. That's the problem. Usually it's in downloads or documents or whatever. So you need to be careful about those. What I did for this project is that I extracted these tables, exported these to the actual database themselves. And so under this add data, I can do a lot of things here, but I can just go to my database right here. And now you notice for geography 4950 data, I've already got the tables sitting right here. And so when I were to go and add these, I can right mouse click, data export. And so if I add a CSV file, and so if I were to go right here and add data and look for, say, a CSV file sitting on my temp drive or whatever, even though it's really messy and really ugly and really whatever. But if I were to go to, store it under my temp, you can see all the different things that I can add here. You see all these TXT files, CSV files, CSVs. I probably have some Excels. The one thing about Excel, adding Excel to ArcGIS Pro, it gets really finicky because ArcGIS Pro has those little tabs right there. Sheet 1, Sheet 2, Sheet 3. So when you go to add these, it gives a little number with a dollar sign. And once you start naming things with dollar signs and pound signs and periods, it gets really fickle about naming conventions. Never name anything with exclamation points because those are going to be reserved characters within our ArcGIS Pro software. And DBF files. So you can see all the different types of kind of text here that we can add in here. But what I did here was I went through and just exported it to the tabular data here. So if I can right mouse click, look at the properties, and I can see that it's sitting in my file geodatabase table, which is what we're doing for this project. Because at one point in time, you're going to go and download this stuff, add it to your project, and do what I do is just export it directly to your file geodatabase table. We want to store it within that little kind of gray cylinder right there. So it's all sitting there, all sitting in that folder. So we're not kind of going to different places. And that's kind of going to be an art that you're all going to have to kind of get used to. Because and to be honest with you, most of you have done a really good job with it. When I first started here, I'd have people kind of looking for data, and I'm sitting there like, I don't know where you stored your data. You know what I mean? So keep it all in the same place. And ArcGIS Pro does a really good job about, hey, I'm creating project 1. It creates a folder called project 1 and then a database within it that you can copy everything into it. Your, CSV files, the stuff that you download, whatever you want to do here. And so without any further ado, here we're looking at standalone tables. What you should have are 3 different standalone tables here. I created a 4th one right here, but I have something called county growth. So now when I right mouse click right here, I've got the county name, the estimate, the numeric change right here, and I got the percent change that I calculated. I got births, deaths, natural increase, net migration. So some of the things that you might see in population geography that we have. Now the first thing that we're going to do here is we're going to run something called a spatial join, where this is pretty cool. I would love to map these things here, but you notice right here, when I right mouse click, there's not much I can do here, because remember on zip codes and counties yesterday, I right mouse click and clicked on symbology and said, all right, now instead of me mapping COVID rates, I want to map median household income or spending on fruits and vegetables, and it gave me a whole bunch of colors in which to do that. I don't have anything here because it's not attached to points, lines, and polygons, but we happen to have a county GIS data layer that is composed of polygons that have perimeter and area and all this other good stuff. And so when we run something called the tabular join as opposed to spatial join, we're not going to do too much spatial join in this class, is that I'm going to add this table, okay? I'm going to add this table right here, this standalone table, County Growth 2020, to the end of my NC counties so that I can map all that cool stuff there and we can see the results. And I have a tutorial on this, but we're also going to do this ourselves here. Now you notice the name on NC Counties is called name. When we look at county growth, it's called county. It doesn't matter that the names are different. It only matters that the information is correct. And you notice here, it's in proper form, meaning the first letter is capitalized, all the rest are lowercase, kind of like your name. Your first and last name are, proper form. It's not all lowercase, it's not all uppercase. So it's here, nice and neat and ready to go. Most of the time, you might have to manufacture these data a little bit to kind of get them in these format here. The one trick here, you notice here under county growth, I've got 102 records. Well, why do you think I have 102 records? We can check down at the bottom here, but I might have something like a total and a source. And so when I downloaded this data from the state demographer in that Excel spreadsheet, it added this little kind of junk right here. But I know there's not a county called state. There's not a county called source, North Carolina. And so when I join it, it's going to kind of magically disappear. Okay, so we're going to get rid of these 102. So we're going to run this spatial join right here. And now I'm going to right mouse click on NC Counties, and this is going to bring up my context menu, because what I want to do at some point in time, I'm going to click on symbology. Instead of mapping median household income or age or whatever, I want to map this percent change between 2000 and 2020 that we created from the state demographer. And I've spoken to that person before at a conference, and they really like some of the stuff we're doing. So, there's always going to be needs for state demographer. It's really neat that blends the stuff that Dr. McGinn and I do. So we're going to go to joins and relates. And we got something here called a relate, a spatial join. We're going to click add join. Okay, add join. So right mouse click on the counties and add join. I know. Add join, good. You got it, Baron? Okay, good. Now this is a tabular join right here. Okay, tabular join. And so when we run this right here, what's the input join field? Well, the county name here, it's called name. And I want to join it to the thing called 2020. So I want to join it to County Growth 2020. This is the table that I downloaded from the demographer, state demographer, that has the top 2010, 2020, the people who come, the people who leave, the people who born, the people who die. So we can do a lot of neat things with this. So just kind of thinking big picture, put it out there, put it out for you people there is, hey, look at all the people who came and left, because you can normalize all these data by population. So we just did one little kind of graphic on this. The join table, and now when I go to this field here, these are all the possible fields that I can map here. So remember under County Growth 2020, the name of the field was called county. So one was called name, one was called county, meaning they're the same thing. Because all we're going to do is, wherever it says Alamance right here, I'm going to add the stuff from this Alamance right to the end. It's got to match up. It's got to match up. Okay, because I know we did this in Intro to GIS, and it gets tricky. It took me a while to kind of figure out joins, and then they talk about inner joins and outer joins and all this other stuff. Okay, if you really want it, you can click Validate Join. This just tells me, hey, when I validate the join, it's not indexed, but it says I have joined 100, and the join table has 102 records. That makes sense, right? Because it had that extra junk at the bottom or the stuff at the top, and I'm going to click OK. And I'm just going to click OK. And a lot of times when you do this, and me coming from command line and this software, there'd be all these kind of bells and whistles that says, hey, your function has run, because it might take a minute or two to run. Usually with this GIS, I'm not overly impressed, because now when I open up NC Counties, what do I see here? Pop 2010, Pop 2013. I'm not overly impressed. But now I go all the way to the right, and now what do I see? I see a county with the key, with the little star there, and now I've got 2010 estimate, 2020, numeric, percent, births, deaths, naturally increased, net migration. And so now we can do some neat things with, like, look at Alexander County. Actually, more people in Alexander County were born than died, but they also gained people because of the net migration there. So there's a lot of like different ways that you can extract data from this, because the whole goal of this class is how to create new information, how to create new data that turns into information. At the end of the day, what do you do with this information? You make decisions on it, right? You make decisions. The whole goal of us is to facilitate data-driven decision making. Making these cool maps and charts and all these other things is the whole goal. Is our whole goal here. But now, when I click on this county right here, like Anson County, now look what I have here. Now this Anson, this stuff right here is highlighted. Okay, and this is the thing I really want to impart on those, especially those of you maybe the learning curve was a little steeper if you've taken some time off of class here. Now if I highlight Wake County here in this table, it's not highlighted. Why doesn't Wake County isn't highlighted on this map here if I highlight it in the table? What's that? Why isn't, notice I highlighted Wake County on this table. Why isn't it highlighted on the map?
Because this is a standalone.
This is a standalone. That's what Baron was going to say too. I think that's what James was going to say on mine too. He beat him to it. But because this is a standalone table. Okay, this is something you do in stats class or Excel or whatever. Okay, but this is something cool you find off the internet that you go and download and say, hey, I want to make some information about this. Now, sometimes it's not demographics, it's ADHD rates, it's birth defects. I got a birth defect map in the back, I got suicide, I got AIDS, I got everything around here. And so the whole goal of this join is to give these tables spatiality. And what we've done right here is we've done this using the spatial join. Okay, and we'll talk about two other functions, and then I'm going to kind of leave you. I'm going to kind of leave you at it, to be honest with you. And so we can right mouse click. We can go to symbology, and then under the symbology, I can do graduated colors instead of pop 2010. I'm going to go down to the stuff that I went through the trouble of mapping, and now this is my percent. You notice here, this is the percent natural. This is the percent change between 2010 and 2020. Do you notice spatial patterns in the state of North Carolina where we're adding people and losing people? Because if we go over here, you can see these yellows and these light greens are actually losing population between 2000 and 2010. You see these? Because what we're going to do next with this is we're going to make some real life maps. So for exercise 2, you're going to make a map, not a little screenshot copy to clipboard. You're going to make a map that we do whatever you want with. That I can insert, that Samuel and I can insert into a research paper that has all like the nice elements of map design. Because at some point in time, I love these maps here. Everyone loves these maps right here. But at some point in time, we're going to have something that's popped up on a poster that people aren't going to laugh at. Okay, meaning you have the wrong colors or you have the wrong projection, because even though you have the greatest data, if your map looks silly, then people are going to think that the data looks silly. And I've seen that happen before. And I've made maps like that back in the day where I didn't put in the right projection. I used odd colors. I used lots of fonts. I'm more of a KISS person. Keep it simple. Keep it simple. But now I can map this here. Okay, I can map net migration. So you can see the net migration, and I can normalize it by POP 2020. So now look at this stuff here. Now I can see where the net migration is highest in North Carolina when normalized by data. By normalized. So we can do a lot of really neat things here, a lot of neat, powerful things here by using the spatial join. A lot of neat things. So I like that. Okay. The next thing. Now, down at your bottom left right here, you got a lot of these different tabs going on. I just wanted to mention a couple of these. And so we've got some bookmarks I've got here. I got chart properties, geoprocessing, this catalog right here. This catalog is kind of like your navigator, like your Windows Explorer. So there used to be a separate application called Arc Catalog, but now it's been kind of inserted into this. And so I can click on folders in my day 2 exercise. So now you can see everything kind of going on right here. Looks like I added to this database some census tracts and things like that with food deserts. And so this map is going to be slightly different. And then I can go to the contents because this thing's called the map. What we're going to be making in a little bit, is called a layout. Okay, a layout which is going to have a scale bar and all that other good stuff attached to it. And I'll go back down here because if I want to, I will I'll create this percent thing. And I'll go here and kind of move on to the next thing here. So I'll click my save here. All right, the next one. So we got the spatial join here. The next thing, I've got Air Max 2020, 2021-04-17. So when I open, right mouse click, open this thing here, you can see 5,670 records. And this was the maximum air temperature that I took on 2021-04-17. So I don't know what the significant, maybe I was designing this class in 2017 where I kind of downloaded this or whatever. I could do this stuff right now. My tutorial that I talk about also does that as well. But if I wanted to, if I can go to the Climate Prediction Center right here, this is the data as of right now. We can go to this air temperature. This is the maximum temperature right here. I can right mouse click and save this right now. I'm going to go to download. So this is Air Max 2023-05-08. So here it is. So I can save this. This is a TXT file saved from NOAA. I'm going to go right here. So instead of me working with this, if I wanted to, I could go add the data. I can go to my downloads right here. And let me look at the very newest stuff I just added. Look what I just added. Is that adding this stuff? Look what I did. I right mouse click. This is the temperature sitting right here as of yesterday. Where did all the commas go? Remember that file that I looked at had commas? Where'd the commas go? What happened to them? Yeah. ArcGIS knows, hey, whenever I see a comma, that's going to be a new column. So a lot of times if you see some misplaced commas, you might see some weird stuff right here. Like up here in this elevation, you see some strange stuff going on right here, but I don't care about that. What do I care about? I care about the lat, the long, and the amount. So in Acadia Valley yesterday, at this latitude and this longitude, it had a maximum temperature 59 degrees. And so you can reference either one of these files here. I'm just going to reference the one that I went through the trouble here of downloading here. But I have a tutorial on how to download these. You can just store the text file here. But you can see in California, Colorado. I'm going to look at North Carolina. It was pretty nice yesterday when I got home. It was like 80 degrees. So New Bern, I live over in Greensboro. So what was it? Maybe there's no Greensboro here. Okay. Greenville. Oh, Greensboro was 79. Now, once again, you notice I click on it, highlight a record in the table. It's not going to pop up because it's just a standalone table right here. And you notice right here, this has got a .txt. So if I really wanted to right here, if I really wanted to, I could right mouse click and do data, export it, and I can export it right to this file geodatabase that we're working in right now. And I can clear these. A lot of times if you if you have a couple of these highlighted and you click export, it's just going to export the blue ones. And so we've got these table operations right here called switch, clear, copy. And if I really wanted to, I could basically copy all these to a clipboard and plop it right into Excel or a spreadsheet application where I can run my statistics too. So I want to turn this into GIS. Okay. So right here under this TXT file or under the Air Max, either one that you're working with, I can right mouse click. And this is called display XY data. So display XY data. So right mouse click on it and display XY data. Right mouse click on that. Display XYZ. You know, he does. You got it over there, Bear? Okay. Those of us joining us online assume you got it there. Okay. Now, X is longitude, Y is latitude. Does that make sense? Yes. Okay. It does. Because remember, X is left, right, kind of like in your math class. Y is up, down. Even though we say lat, long, we really say it a little bit backwards. All right. Next, the coordinate system right here. Okay. Coordinate system. We're going to click on GCS WGS 1984. Okay, that stands for Geographic Coordinate System. Geographic coordinate means angular distance. These numbers right here, this negative 80.75, what units are these things in? Yes, what units are these in? Angular coordinates, how much something opens up. And so we bring in all the sines and cosines and all that other stuff here that the computers figured out. When I did this in 1999, they didn't figure it out quite as easily. And so you want to make sure it's coordinate system. If you need to, you can click on the little world button, and I can go to, not my favorites, but I can go to geographic coordinate system, and then go down to world, and then click on WGS 1984. There's a WGS 1972. There's not going to be that much of a difference because the Earth really hasn't changed that much. Okay, and the reason why we have all these different coordinate systems, especially with the geographic coordinate system, is because the size of the Earth is changing slightly because of the way that we can actually measure it. Okay, the way that we can actually measure it has gotten better. So 1 degree of latitude is 70.1257936 instead of 70.125937 miles. Like we're talking about like millimeters to the, we're talking about millimeters, really, really small. And so when I click OK, what happens? What do you get? Does this make sense? Does this look what pops up here? And now, if I look in my table of contents, what do I have now? I've got a brand new feature class sitting in my table of contents that I called, in this case, Air Max XY table to point. You could give it whatever name you want. And now I can change the attributes on this thing. Look what I can do here. So now these are all things in North Carolina. I can just select everything in North Carolina. Remember we did that yesterday where I can say, all right, select by location. I want to find everything that intersects with North Carolina and just work with everything in North Carolina. So if I really wanted to, I could get rid of everything else. So I can highlight everything in blue. And then I can go to Data, Export Features, and now just work with everything in North Carolina if I want. If I'm doing analysis, I typically don't want to work just with everything in North Carolina. I usually want to create like a buffer around it because the temperature just over the border is going to impact what's going on here. And now I can do some of the neat things that I have here where I go to symbology. Now, what type of symbols do we work with here? We can work with things like graduated symbols where let's map the amount. So this is the temperatures that we have here. So this is the temperature, maximum temperature yesterday. Where are the temperatures the highest? The highest in the mountains? No. Highest in the coast? Not right at the coast, but kind of in this middle area right here. Because everyone knows about the coast, it's windy, temperatures are down a little less. So you can see these patterns attached to this, and then you can kind of see, I think see over here, the impacts of the urban heat island as well. So some pretty neat analysis that we can do right here. So 5 minutes ago, this stuff was sitting at a web page at a no website. Now, what are we doing here? We're creating temperature maps. Are you impressed with this? You like this stuff? Pretty neat. This is my skill. This is kind of the stuff that I'm good at here. Now, what are the things you can do with it? You all figure it out. We can look at things like temperature range. If you Years ago, we had a student who took the max temperature, the min temperature, subtracted them for each of these and found the temperature range. And so right near the coast, near the temperature doesn't really go too far up and too far down. But over in the mountains, it gets really highly variable. So if you're thinking of a project where you want to do that, hey, go through, do the max, do the min, subtract them, let's map them. Let's look at some of the changes. How do these changes change across 2 or 3 days? Some really, really neat ideas that we've got there. And so we've got these here. I'm going to show you a mistake here because a lot of times the biggest problem that you run into is everyone can do things right when you click and point and do everything. But what happens when stuff doesn't come up that you don't want to come up? So I'll show you a quick little mistake that I run into. I'll show you an example of geocoding, and then we'll take our charge for the day and go from there. And so a lot of times if you see this Air Max right here and you do at display XY data, one of the things, what if you did latitude and longitude? You grew a brain and said, hey, I better look at that X and look at that Y because I say XY, I say latitude, longitude, and now when I do it, look what happens. What happened? Oh, look what happened. What I do? I switched to latitude and longitude. How high do latitude values go up to? -90 to +90. But now the computer's just, hey, you want to give me a latitude less than 90? Here it is. Here it's less than 90. If you're out in Hawaii or wherever, my kid lives in Hawaii and he's at like -120, -120 longitude. How high does longitude go up to? 360, -180, or goes from +180 to -180. So 360 degrees of longitude, but only 180 degrees of latitude. So this computer, like I told you, it's stupid. It'll tell you, hey, look what I gave you. I did what you told me to. Okay. And I'll give you another instance here. So make sure at the end of the day, you are the final GIS user right here. I need to kind of stress that. Zoom to layer. And then if we did something like this, if we did it display XY data, XY, and I said, you know what, I really think this is the North Carolina State Plane projection, which measures things in feet. And now I'm going to run it. I'm going to do Latin long. What happens here? Let's see. It ran it. Where is it? Look where it stuck everything. Wow. So it stuck all 5,000 of these points like right here. Down in Alabama. What's the significance of Alabama? Why is it sticking it in the middle of Alabama? What's so special about Alabama? Anyone who took 4010, let me know. I see Benjamin. I see Lauren. I see James. What's the significance of Alabama? Marlene. Tony.
The center?
The center of what?
The equator?
Close. You're on the right track. You're on the right track. That's the 0 point for the North Carolina State Plane projection. So North Carolina State Plane sticks everything onto a flat surface, measures everything in feet so we don't have to deal with this sine, cosine, tangent garbage, and puts the 0 point down in Alabama so that everything in the state of North Carolina is in the first quadrant. What does the first quadrant mean? Both values are what? Positive. Because here in the United States, we're in the second quadrant. We got negative longitude, positive latitude. South America, you are negative, negative. Because in North Carolina State Plane projection, it doesn't care about the other states. They could be negative, but everything in North Carolina is positive. So that's the significance of that. And so when we have values like 92, 93, those units are in feet. So literally like 92, 93, 94 feet from this 0 point, because when we look at that North Carolina State Plane projection, those units right there, and if you really wanted to look at these in feet, These are the units we're working with. 31 million, 2 million, 3 million, 4 million, millions of feet. So millions of feet right there. So a lot of times, unfortunately, the best way to learn is by making major mistakes. And so when you see these mistakes, they're not going to pop up nicely and neatly on top of each other every time. The last thing I'm going to show real quick is this thing here called geocoding. This is Durham Police Department crimes. So you can see there's 118,000 records that I downloaded from that OpenGIS website. 118,000 crimes. So you can see the date, the year, the month, the charge description. We can convert these to day of the week because at some point in time I want to do day of the week stuff. And so if you know the date, Excel actually has an application that if you have the date, it'll convert it to, it knows the day of the week. Because I like looking at these things here. Now I don't want to sit here all day and do this. So what I did was I right mouse click and just extracted out the May 2020 crime. We had a couple of students who went and did crime analysis. A student who came to us from criminal justice, who they looked at pre-COVID crime versus COVID crime. They extracted out all the May 2019 versus the May 2020 and looked at patterns of crime between the two using a nice little two-tailed t-test. They said the patterns of crime went down. Patterns of crime went down. Crime rates went down. But the one thing about COVID, it made violent crime actually go up. Assault and domestic violence and all these other things that I thought was interesting, by looking at the actual data. So what I have here is 2,222, kind of an odd number right here. And now when I look at this here, is there any way that I can find location here? The only thing that I've got right here is, like this thing here called an address to. That's the only thing I have right here that I got to figure out. Now, have you ever typed in an address and gotten a point out of it? We do this all the time. Who wants to do this 2,222 times? I don't. I definitely don't. Now, we need to qualify these things because 4100 Lumley Road. How many 4100 Lumley Roads are out there? I don't know either, So some of the things that you do, we call this kind of data cleaning or cleaning it up. If we really wanted to, we could add a brand new field called city. What do you think we should put in the value for the city? Durham. All right, let's just go calculate Durham in here. So I'm going to go to Fields View, and I'm going to just go down here and put in the word city. It might be able to run without city, but I'm just going to show us how to do it. So I'm going to put in the word city. I'm going to put in a text, and I'm just going to make it 20 characters long. I'm going to click Save. And now, under this Durham 2020 crime, I can just go and type in the word Durham, right? So D-U-R-H-A-M. All right, hold on. I'm going to do it again. D-U-R. So I'm just going to have to do this am I going to do this 2,000 times? No. Okay, so I'm going to right mouse click. This is where we can calculate fields. A lot of times we think of calculate fields with values, but city, I'm just going to type in the word, quote, D-U-R-H-A-M, and there it is. Do I know that every single one of these addresses is Durham? It might be because we have places like Chapel Hill, Mooresville, Raleigh, Bahama that are actually within Durham County, but who's going to go and figure all those out? Not me, for all of these here. And so we're going to run this geocoder right here. Now, the one thing about geocoder that ArcGIS has done is that they have learned to take advantage of these geocoding services. So I've got a link to our geocoding services, and the reason why I'm just showing you how to do this is because if everyone in class ran it like 10 times, then we'd run out of Esri money before the end of the year because it costs money. And remember when we did this in our 40-10 class, I only did it for like a few hundred points, and I had us just run it for a few hundred points. So it costs money. We had someone in criminal justice who did this for like all of Atlanta for, over a period of year, and like our credits went down. I was like, hey, just do the stuff you want to do because, even I don't realize how much this stuff costs. So we connect to a service. A service is basically, it just sounds like it's somewhere sitting on another computer. I'm going to click Save Link As, because, no, I'm not. I'm going to do Copy. Well, I'm going to try it. Let me make sure. And so I'm going to right mouse click and do geocode table. So I can go and geocode this table. When you open up the geocoder, I'm going to click Start. And what I have done is I've actually saved it in my hold on. I've saved it in a special place. Favorites. Add to project. So under my items, under my catalog, I've added this already. Is this what you were thinking of, Samuel? Here it is. So it's called the World Geocoder Service. So basically, you got to figure out how to add the service. So I've got a link to that service. And what I did was I added it in catalog. I created that as a permanent connection that I have. And then I just added it to my folder. So you notice I went back, added it to my project. And so now when I clicked on my project, it was there ready for me to add instead of me always adding every single service to every single project. There's other services out there like the NCDOT imagery server or the Department for Cultural and Natural Resources has a server. Our goal someday is to have our own service that we publish stuff on that people can utilize. So instead of me putting stuff on a flash drive, I can download the imagery here. And so what I did was basically call up that service. And now I just said, all right, I've got address 2. I got a city called the city. I'm going to go to my next. I'm going to call this output feature class May 2020 crime geocoded. Next. I'm just going to say it's in the United States. And then I'm ready to run it. And when I run it, watch what happens. I swear something's going to happen. Oh, there it is, down at the bottom. So you see matched, tied, unmatched. So you can see I can do about 500,000 of these an hour. And now what happened? So when I finished up, I had about 98.47 of those matched, 1 unmatched, 33 tied. Those might be like 20 Main Street in Durham, but there's a 20 Main Street in Mooresville, which happens to be in Durham County. It says start rematch process. I never do that because then you have to go through all 34 that didn't match up and go through them by hand. I'm not going to do that in this class. And so now when I have these geocoded features, let's see what I got here. I got my 2,222. I'm going to do my zoom to my layer. Look what happened. Look where one of these points showed up. Portland, Oregon. So there might be a Durham right outside of Portland. I don't know. Who knows? I guess it found Southwest Durham Road, Portland, Oregon. Because a lot of times when you look at these addresses here, if we were to look at the May 2020 crime, if we look at some of these have some really like 0 Sparger Street, Lady Banks, Lee Street. Some of these aren't going to be in the right place. 0 Knightsbridge Court. It gets into some spelling issues, spelling sensitivity, all these other things that, I don't want to get too much into today because you could do this as a project. Hey, I want to go match all of last week's crime. How much of this stuff actually worked? How many, 98%, the week before was 92% or whatever we've got right there. And so you can see there, one of them showed up in Portland, Oregon. The rest of them, look what we got right here. We got the rest sitting right around Durham. This look right? Probably most of them are going to be right. Yeah. And now we can group these within zip codes or block groups or whatever we want to do. We can make our heat maps. We can extract out homicides or do whatever we want to do. But, 10 minutes ago, this was sitting on the Open Durham GIS website. We download it. We run a nice little geocoding service and we're set to go. Okay. Well, that's about it for me today. The assignment, I'm going to go through the assignment and I think we'll be done. I know we'll be done. So today's exercise is we're going to be making a map from tabular data. And I want to click on student view right here. So what you're going to be doing is making a professional level map, a map that you're going to save as a PDF or whatever you want to do here. You notice I've got a link here to this Google Drive. So if you want to link to some of the data we have sitting there, feel free to. If you just want to work with the data that we already have sitting here, you're more than welcome to do so. You're more than welcome to do so. So if you want to kind of work with the extracted data, because doing the joins and links is just one part to creating the map here. And so in this instance here, I mapped increase rates. So I mapped increase right here. You could do it for ADHD, homelessness. You could do it at the zip code level because you notice here I added a number of zip codes. So I've got some COVID data sitting there on the zip codes. But this practice is going to be in a practice in joining and then inserting. We're going to be making brand new layouts because this map is really cool. But you notice I can't put any writing right here because this is like real world location data. I've got real world data sitting right here. So what I need to do is I need to insert a layout. And I've got a tutorial on this, but I can insert a brand new layout. And I'm going to insert a letter layout. And now when you see it right here, I've got a brand new kind of feature right here that's 8.5 by 11. What happens to be 8.5 by 11? Piece of paper. So this is going to be the piece of paper that you put things on. Now the very first thing you need is a map frame. Well, what's going to be your map frame? The stuff that we went through the trouble of creating here. So I can make a brand new map frame right here. Now, look what I got right here. Doesn't look all that right, but we can kind of tweak it and all that other good stuff. So now this is what our piece of paper is going to look like. Okay, this is what our piece of paper will look like. So now I could do some inserts and all that other good stuff with my map frame. I always mess this thing up where that I do navigate, and I can click on not navigate, activate. So I can click on activate and then move this county, move the state right over. So I can do activate, I can change the scale, I can zoom in, I can zoom out, I can do whatever you want. This is what my piece of paper is going to look like. So now I've got a layout, I've got a map. So this is the actual map. So if I uncheck this thing here, then this is going to be unchecked. If I check this thing here, so this layout has a direct relationship, direct link to that map. So however I change that map, I change that layout. And so, folks like me and Samuel, when we're making our maps for our research projects, it's always tricky keeping track of the maps and the layouts. I always have trouble with that because they're interconnected to, they're connected to each other. It's always kind of a big pain in the neck. So I got my map, I got my layout, and then when I'm done kind of moving this thing around, I click close activation. So now I can't move this map around. I can set a bookmark, meaning it's a spatial bookmark to zoomed in where I want to do. But my big thing I want to do is insert. What do I want to insert in here? I want to insert north arrows. So I can insert a north arrow right here. I can insert scale bars. I can insert scale bars right here. So I swear I inserted a scale bar here. Yeah, here we go. I got scale bars. When in doubt, right mouse click and you can open up the properties. You can go and change the background to every single one of these things here. So I can change the text symbol, the background, the appearance. You know, and folks like Samuel are really, really good at manipulating these things. I'm not very good at, digging into the properties or whatnot. I'm not the best map maker with this. The previous incarnation of our GIS software was really good at making cartographic products. This thing, it'll make a nice PDF, JPEG map for you, but it's more geared to sharing these things online, integrating with the web and clouds and everything else. But if you want to make a high quality map, you'll just have to kind of dig a little bit further than you did in the previous incarnations of GIS. But now, up in this insert right here, we can insert legends, scale bars, text. If I want to insert a symbol right here. So if I want to insert oh, here's one. I can insert this, whatever. This, you can insert logos or whatever you want to right here. I can insert text right here. So I can insert, this is, what am I looking at right here? Percent, whatever we're looking at. Growth by county. And now you notice you can move these things over. You can make these things bigger. You can put backgrounds on all these. It gets really kind of, you can get really good really quickly. But now you notice when you click on layout, each of those elements in the table of contents, you can see that I've added a text, a picture, a scale bar, a north arrow, an actual map frame. So if you really want to stick a map, small reference map inside of this map, you can do those. And if you've taken my 34-35 class, they do some neat things in like the early chapters, chapters 2 and chapters 3 on cartography. We focus on the colors. We talked about the greens and the purples that you might want to do as opposed to the reds and the oranges. But what you're going to do here is you're just going to create a high quality map. You can do anything. You can do the map that you already started, or you can link to that those Excel spreadsheets on the Google Drive and make something that you want to do on homelessness or libertarian voters or whatever you want to do. Because when we're done with this, what we want to do, we're going to click on share, but we're not going to share, we're going to share this layout to a PDF. You're going to export this thing to a PDF that you're going to give into me. And so the big thing we want to make sure you have is essential elements of map design. We got a north arrow, we got a legend. What's that? Yeah. A legend, north arrow, scale bar, definitely a title. And then it just adheres to those kind of principles of visual hierarchy. So we want, this percent growth. I definitely want this thing, I want this thing much bigger. So I can click on the text symbol, appearance, and I want to make this thing like, font 22 or whatever instead. I don't like these boxes and things like that. And I can change the background and, whatever else. And whatever else I want. And I think I can change the background in here somewhere. Right, Samuel? Yes. Oh, I can change the background in here as well. Something that's going to be, people are going to look at. So, your kids to your grandmother can understand what it means. I've got that thing there called percent. Maybe I want to change it to, single click on it, percent. Growth. Okay, so people might not know what percent means, but I'll call it percent growth. And so those are some of the kind of the small details I've been having Samuel work on our maps, where that we need to qualify what we're unit. That yellow thing right there, what is it? All right, it's a 15 to 37. I don't know what 37 means, but okay, it means percent growth. Okay, so I know everything in that yellow is highest, everything in the green is the lowest. So we might want to switch those just because yellow should be lighter or less, but I've got my legend in there. So you got a lot of properties to go play with. You got a lot of neat things to do because at some point in time, you're going to need to make a nice PDF or JPEG of this that you'll insert into a paper, PowerPoint, or whatever else that we have. Anything else that you can think of, Chris?
Nope, I think you got it pretty much covered.
Yep. And this will be due on the 19th, so a week from Friday at 1 o'clock, the beginning of our kind of finals class. Those of you joining us asynchronously for the final project, I've posted some screen recording software so you can meet with me and Chris offline so that you can do your presentation, record it, and then we'll post it for the class when we meet from 1 to 4:45. So don't worry too much about that if we're kind of looking ahead. And so for this assignment, you're just going to click upload. And so you're just going to upload the, PDF, a nice high quality PDF. I want everyone just kind of getting the idea of linking, joining, creating data, and then making high quality visual products that can be understood by anyone from age 9 to 90. So tomorrow we'll be flying drones. It'll be exciting. I've already uploaded some imagery. It's pretty cool of campus. So if it rains or anything tomorrow, we've got it here. The biggest pain in the neck is just you sitting around twiddling your thumbs, waiting for it to process. It's really easy to capture, really neat to capture, but waiting for it to process and making some sense of it, that's the big thing. And so tomorrow we'll plan to be outside for a little bit, give you all an opportunity to fly it, capture it. And while I'm thinking of it, if you want to add, it's called DJI Fly. What's it called? For iPhones, it's called DJI Go 4. I'll mention that.
DJI Go, yeah. And if Androids, there's all kinds of issues. I'm working through it. You might have to download it from the actual website,
Okay.
which is DJI.com. And then it has downloads, and you can find it if you have an Android. Or if you want to do that tomorrow, if you're playing with it in class, we can mess with it.
Yeah, and that's some of the issues we run into with the software. But this DJI just basically plugs into our connector and it talks to the drone, and you just use this thing as like a little control thing to fly the drone. So it'll be neat. And we'll kind of proliferate, creating your own data in how to create your own data. I look forward to it, and it should be good. So I'll see you all tomorrow, and I'll be around. Baron, you have a question? Oh, okay. Click on day number 2. And recording, I'm going to stop the recording right here. So, and I'll come answer your question here in a second.
Yeah, and for everybody that's online, Isaiah just asked a good question. Dr. Maroney attaches these recordings in the announcement wrap-ups that he sends this afternoon. So if you need recording number 1, it is in the most recent announcement he sent yesterday afternoon at the bottom there.